In this lesson, we will illustrate how the convergence feature of Workbench can be used to accurately calculate the stress in the fillet region of the model shown here. We'll begin by clicking on the simulation icon, and then, after the simulation window opens, we'll click on Geometry in the outline window. Now, from the Geometry pull-down menu, we'll select from File, and then select the file T Section 3D. We'll next verify that the working units are set to US Customary. From the New Analysis pull-down menu option, we'll now select Static Structural and then rotate the model so that the back portion is visible. We now need to apply a fixed support to the top, back, and bottom faces, so we'll start this process by making sure that the Static Structural folder is selected, and then select Supports and Fixed Support. Then, after making sure that the Face Selection filter is highlighted, we'll click on the back, top, and bottom faces, making sure to hold down the Control key to allow multiple faces to be selected. We'll now click on Apply in the Details window pane. Our next step is to apply the load, so we'll start by clicking on the Loads button and then select the Force option. We'll now rotate the model so that we can see the opposite end, which we'll now select. Next, we'll click on Apply in the Details window. In order to change the way in which the direction of the force is defined, we'll click on Vector and then change the method to Components. Then we'll enter -100 for the Y component of the force. In order to display the model with both its supports and loads, we'll now select the Static Structural folder. The last step prior to solving the model is to select the type of results we wish to calculate. We'll do this by first selecting the Solution object in the Outline window. Then, from the Deformation pull-down menu, we'll select Directional, followed by changing the orientation to Y-axis in the Details window pane. Since we also want to calculate stresses, we'll click on the Stress pull-down menu and then select the Normal option. And then we'll make sure that orientation is set to X-axis in the Detail window. Since we have now completely defined the model, we'll click on the Solve button. We can now observe the stress results by selecting Normal Stress in the Outline window. As you can see, the maximum tension normal stress occurs in the fillet area on the top edge of the beam and has a value of 10,733 psi as shown in the legend. We'll now start the process of refining our solution by first making a duplicate copy of the model. This is done by selecting on the Model icon in the Outline window and then clicking the right mouse button and selecting Duplicate. Next, we'll select Model 2 and then click the right mouse button and select Rename and then key in Convergence Model. In the new Convergence Model, we'll expand all of the items and then select the Normal Stress icon, and then click the right mouse button and select Insert and Convergence. Next, we'll click on the value of 20% and change it to 2%. And finally, we'll click on the Solution folder icon and then, in the Details window pane, change the Maximum Refinement Loops to a value of 3. We'll now solve our convergence model by clicking on the Solve button. After the analysis is finished, we can see that a converged solution was achieved by noting the green check mark next to convergence in the outline window. We'll now review our results by first clicking on convergence and observe the chart showing the results as a function of solution number. As you can see in the table, the maximum normal stress found in the fourth solution is 13,569 psi. The graph also shows that the fourth solution showed a very small change compared to the previous run, which indicates that a converged solution was achieved. As a final step, we'll now display the graphical image of our converged model.